begin. Let's talk Flat Earth 2. We have two very special guests today. We have Joshua Hamer, who is a Flat Earther. We also have Stephen, check his last name, Stephen Hitchens,
Absolutely.
who is a fully trained, licensed pilot. It's awesome to have you both on the show. Josh, it's good to see you again, sir. We also have John Finch, Outfox Studio, hilarious guy. It's my co-host for tonight. So let us begin, gentlemen. I guess my question, are we starting with me or you want to go first, John? How do you want to do it?
You want to do it? You're the host, mate. I'm just going to sit back, draw things on
so
the
you can
pad.
relax this time. All right. My first question would be, I would have to ask, like, again, I guess the same question because it didn't really get answered the first episode, I don't think. How did you get into Flat Earth? What was the initial thing that made you something click and be like, okay, well, I believe the Earth is flat, and tell me why.
As in physical evidence as well. What physical evidence?
Yeah. Physical,
right.
Anything.
Yeah, and I might have just in the attempt to try and introduce different aspects of it, because it's more that it's a multifaceted answer. But for me, one of the biggest things was really just like I summarized last time is there's just stuff you can see from so far away that it's like, whoa, that we shouldn't even be able to see that. From like,
so I suppose you're using the 8-inch mile squared thing.
No, well, because the 8-inch per mile squared is that like doesn't mathematically create a sphere. I mean, it could define the first mile, and then if you start over, it could define the next mile. But that's why you have to there's another aspect to the equation when it comes to a curvature all the way around to the sphere.
What calculations are you actually using then? So when you say that you shouldn't be able to see a certain thing over there, how do you know that you're not supposed to see it?
Well, what's funny is when you use an 8-inch per mile square, you actually get a curve or a parabola that's easier to see around. So if you were to calculate it based on a sphere, then it should be even farther around the curve before that it goes when you can't see stuff. I'm sorry, let me just start over and rephrase that entirely, because what it comes down to is, yeah, you can see stuff from really, really far away, and I'm getting distracted. I feel like, can you guys see me okay? There's I feel like there's a huge glare outside behind me, but
it is very bright, yeah.
Yeah, so I almost want to just turn away from the windows, but sun's going down here anyway. We can talk about that later next time, or later in this next topic, maybe, who knows. But all right, I digress. You can see stuff from really, really far away, not just across Lake Michigan. There's lighthouses that can be seen from 4 times away further.
Yeah, but what measurements are you using? How do you know that you're not supposed to be able to see that particular object from that distance? If you're all using the wrong measurements, you're all using the 8-inch mild squared thing, which, like you say, it's wrong. It's the wrong shape. It's like trying to measure a square but using the measurements of a triangle.
No, right. So I get what you're trying to say, but my point is, even if you use 8-inch per mile squared, which is the first mile, then after that, if you use 8-inch per mile squared, mathematically, you should be able to see things from way farther. But if you use the spherical model, it makes it even harder to see stuff that's further away. So to answer your question, the spherical model, you don't need to use. My point is, if you use 8 inches per mile squared, like a lot of these flat earthers will do, go ahead, use it. I don't care, because you should be able to see stuff you shouldn't be able to see it still. And the real globe model curves sharper away than 8 inches per mile squared. It's not a parabola, it's a sphere. And so a parabola is like this. So imagine I'm on the top of the parabola and I'm looking down, and you're trying to calculate with 8 inches per mile squared, how far can you see around the parabola? Well, that's going to be easier than if you were trying to look all the way around a ball.
Yeah, but that's my point. If it's supposed to be harder, why don't they use the real? Why don't flat earthers use the real measurements for it? And they can say definitely, but why are they using? They're using mathematics that they haven't got a clue about.
That's not necessarily
come up with their own completely. It's like twisting science their own way and thinking. But if you look, it doesn't make any sense.
Hold on, flat earthers use X and Y, and we have this flat, and then we have horizontal, and how can we still see it, right? But on the same map, if there's a predictable curve that's circular all the way around, technically at some point there's going to be a point on that curve where you're going to go down and around, and then eventually the line of sight is going to be interrupted by the land and the curved earth in between you and whatever it is you're looking at, because when you talk about these vast distances, what ends up happening is you're looking at something, and so see how we get into the debate, and it makes it really hard for me to answer the question.
Like my initial question, though.
So many of them.
I'm sorry, you can't have both of you talking at the same time because it just cuts out the sound and we lose whatever's being said anyway. So Joseph's just jumped in there, and he's the host, so I'm going to let him carry on.
Yeah, go ahead.
No, just my initial question, like what we could debate the models, but when you break it down, what pinged in your mind to make you think that the Earth was flat?
Well, so I want to answer it, right? And what happened is, without going into all of the math, because I've done the math before, right? I don't.
So what are the real calculations to measure the curvature of the Earth? Then, if you've done the calculations.
Well, see, that's what I just said. I said I don't have the mathematics in front of me right now, and I don't have them memorized.
Well, no, what equation do they use?
I like I said, I don't have it memorized. I don't need to. But the closest one that people want to debunk all the time is 8 inches per mile squared, which is what people say, well, that wouldn't make a
It's completely wrong measurements. They can't measure the curvature of the Earth with that.
Right. So So I at the behest of
no, before you go on to it, mate, Joseph is dying to hear the answer to his original question.
Yeah,
this is what happened the first time.
So what came to me was, one, there are things that are very, very far away, and I would challenge you go do the math. Why don't you tell me the equation? If it's not 8 inches per mile squared,
it's H equals R minus R cos S2R. Does that make any sense to you?
Something. I got something here. There's like crazy math numbers, right? And so I got, in order to calculate centrifugal force, you have to do F equals M mass times velocity squared divided by radius of the
centrifugal force wasn't what I was asking.
My point is,
well, just go back to Joseph's original question. He's gagging for you the answer.
I'll give you easier ones.
There's stuff that's really, really far away that breaks the math. There was a guy that went to a math professor, right? Because some of these questions get so tricky, you have to go to your math professor. And he goes, hey, there's this island that's across, and it's such and such far away, and we just want to know if on a ball, if it's supposed to be visible because it's so far away. Here's how far away it is, and here's the elevation, but we're at sea level, so the elevation is just nil. And how far behind the curvature, behind the horizon, should we be able to see it? And the math professor's like, oh, no problem. And he goes and scribbles it up on the thing. And he goes, yeah, here we go, blah, blah, blah. It should be X number of feet out of sight. And then they're like, well, but we can see it. And so that's the whole point that I'm trying to make. That was one of the biggest things for me is you can still see these, and they
the
break
science
the math.
professor is what started you off. That's the very first thing. This science professor, you watched him, and then that started you off.
There was multiple. I went and did the same kind of rabbit trails you guys are trying to do with me. See how when
I'm trying to ask you, what was the very first thing, or don't you ask,
really
what was the
away.
very first thing that went, wow, we're on a flat Earth?
The answer is you can see stuff from really, really far away that you shouldn't be able to see if it's curved.
I want to bring, that being said, I'm excited about this personally. The pilot, he's an excellent dude, been doing it quite a while. Steven, we were talking before the show about some interesting points. What is one top point that you can use to kind of give Josh an idea as to how, just do your thing, my friend.
Sorry, I've just got to ask you just a couple of questions just to clarify for any flat earthers watching, just to make it nice and clear for them. Let's see. First one, are you or have you ever been a member of staff of NASA?
No.
Are you or have you ever worked for a secret government organization?
No.
Have you or have you ever been a holograph projection or CGI?
I wish. That would be really cool.
Just so we got that nice and cleared up. So you're listening, flat earthers, you can sort off for those comments that are saying he's working for the government, he's working for NASA.
Right, I wish I were that cool. I wish I had worked for NASA. I wish I was an alien.
And what, are you sworn to secrecy? And if you are, would you tell us? And if you told us, should we believe you?
That's up to you.
No, I'm not. Like I said, if I were that cool, I wish I were that cool, but I'm not.
Yeah, so we got to get down to brass tacks, self-verifiable facts, but I love the conversation.
Sure, that's fine. We can start with that. To go back to the initial question, the first couple things that I would use to start my argument are the way pilots use a compass to navigate, the way pilots would use a GPS system to navigate, and then a couple things that wouldn't prove or disprove either way. And that would be that on a globe, the atmosphere would also be curved around that globe because of gravity and how from every direction gravity would pull in a certain pull perpendicular to the surface. And because the atmosphere is curved, as you would go around that globe, the airplane would change its angle relative to the atmosphere if it were to fly straight out from a globe, which it doesn't happen.
Kind of.
So if I can go ahead.
Oh no, I'm sorry. Kind of like a side note for those watching that may or may not know, could you give like a brief description on how a compass works?
Yeah, so let me start with how an airplane flies, and then we'll get to how it navigates. If I can share my screen, these are the four. Can you all see that?
I cannot.
I can, yeah.
Loading.
Would you be able to send me all these photos that you use so I can?
Sure, yeah, I can send those as soon as we're done here.
Yeah.
These are the four forces that an airplane encounters when it's flying. We got lift, weight, thrust, and drag. Thrust is always going to be in the direction the plane is moving, drag in the opposite direction, and that would be just the atmosphere is slowing the airplane down. We have lift, which is generated by the wings, and weight or gravity generated by the Earth towards the planet Earth.
Objection. Just kidding. Keep going.
All right, so if we can switch back to my camera here, if we have this little jet, gravity is always going to be toward the Earth. If we have a curved Earth, that means as we go around the Earth, gravity is still pointing down towards the ground. So as we're flying along, the vector of gravity towards the ground may be rotating, but it's going to rotate with the surface of the Earth, like that. The second thing is, I mentioned the atmosphere. The atmosphere has the same, or the gravity has the same effect on the atmosphere as it would anything moving around the surface of the Earth. So it's going to be curved around the Earth, meaning that if you go higher, you're going to encounter thinner air, and if you go lower, thicker air, because gravity is going to pull the highest concentration of air towards the Earth, and as you go away, you're going to have a lower concentration of air. If an airplane is flying straight along, and let's say as we fly, if this is our Earth and we're flying straight, you might think, oh, you just fly straight along and you have to start pitching down. No, gravity is going to pull you down perpendicular to the surface. Even if it were rotating like this, gravity is going to pull you perpendicular to the surface. Since the atmosphere is curved around the sphere, if you were to go straight away from the planet Earth, your angle of attack, which is the angle between the wing and the atmosphere, would increase. And as it increases, you generate more and more drag behind the wings, and eventually the airplane will stall, meaning it will fall out of the sky. This doesn't happen as we fly straight and level. We start curving around the Earth because the atmosphere is curved, and that vector from gravity is constantly changing its angle relative to our initial direction of flight. So that's why we as pilots would have to do nothing in order to fly at the same altitude above the surface of the Earth as we were to fly around the Earth. Now to talk about two ways that we navigate as pilots, and that would be via a compass, which is a little outdated and we don't really use most of the time. We use it for reference, and GPS. So if we talk about a compass, the inside of the Earth, we have a core made of liquid iron. And because it's tumbling around and the Earth is spinning, we create helixes in the center of the Earth that are rotating like that. Those helixes create a north and south magnetic pole and a magnetic field going out from the poles, wrapping around, and coming back into the south. And it's a very abstract concept. We're not entirely sure how magnetism or gravity or any of those forces work, but we know how to measure them, and we know the reaction of those forces. We don't know the causes, but we know how they affect the physical world. So if we have a magnetic pole, which is not locked to the outside of the Earth, remember it's the inside that's liquid and tumbling around, that means the magnetic pole is not going to be necessarily the geographic north or south pole.
That's the difference between magnetic and geographic north. And I do want to intercede at some of this point, because I mean, I don't want to waste all this time with like middle school geometry type of stuff that we were taught, and all of us know how to recite back about the fact that the Earth is supposedly doing this because we know it's a globe. It's doing this, and you know, assuming that that as a flat earther, I don't understand this information and how it's explained in a flat Earth model. But I have a lot of questions for how this is supposed to work that you've kind of overlooked some of the things that I feel are really important questions. If it is a globe, then why not this? If it is a globe, then why not this?
Well, I'm
And
getting to that point with the magnetic.
Well, all of these things you're telling me work just fine in a flat Earth model as well.
This
and
will not, if you let me finish this one point.
Suppose that you don't understand how it is possible for any of these things to actually work on a flat Earth model. And out of all of the multiple things, I have 1, 2, 3, 4, 5, 6, 7 things that I've noted and listed, which have a globe explanation that you're presenting in a way that assumes the flat earther doesn't also have an explanation for that in their model. And that's why I'm here to defend and stand up against the propaganda that says the way you're explaining things right now is the only way to see it. And that's why.
Okay, let me get through my explanation, and then you can give me yours.
I would love to rebuttal
right,
each
let Stephen finish, and then you can have your say. You know what I mean? So we'll do it like a court, where you got your defense and prosecution, right, one at a time. So please let Stephen finish.
Oh, of course.
Two quick.
We don't agree on models on how we're going to debate and whether I can or can't. So I had to be rude again and interrupt there like that, like I said. And
right. Well, like I said,
I apologize for that. Yeah.
You can counter whatever Stephen says once he's finished, but he's got to finish first.
No problem. Just
all right. Yeah. Two more quick things, and then you can give your explanation for these same phenomena if you want to. Sure. Okay. So magnetic declination is how we differentiate between what a magnetic compass is going to read on the ground and the difference between that and true north, which would be directly towards the geographic North Pole. Here's a map of the declination between the northern United States through Canada. We got Alaska over here, Greenland, and Iceland. These lines show you if you are on the ground and you measure your compass. The red line shows what direction magnetic north will be. So if you're on the ground in Seattle, magnetic north is going to point about, I think that's 20. I think that's a 20. About 20 degrees east of where it should point for true north, which would be this direction. These lines would make no sense on a flat Earth. If these lines are accurate, which I believe they are, and they change from 95, that's another thing. The magnetic north does not stay the same. Magnetic north is constantly changing. And in the geographic history of the seafloors, we can actually see when the magnetic north and south pole have flopped around based on the magnetic orientation of the rocks in the seafloor, which would have no explanation as far as I'm concerned on a flat Earth. This is another diagram of magnetic declination. I'm not sure what year this is from, but again, it would change year by year. These lines, if this were a flat Earth, these curves would not make any sense. And it kind of goes the same way with our flight paths across the Atlantic or something.
We can talk about flight paths.
Why would we fly this curve? It makes no sense if our Earth is flat. But if we switch this, I don't know how to switch it now. Let me refresh the page.
Which flat Earth map are you using? Because on the flat Earth map that I use, that looks like a really straight line. It looks like the shortest flight path, actually.
Here, let me stop sharing. I'll do this demonstration with my actual thing here.
Okay, because I mean, we've gotten into a lot of different topics here that I'd love to start rebuttaling any of these, but
Okay, let me cover GPS first, and then we'll get
a magnetic declination. I mean, finishing is great, but we don't just want to have you finish all the topics, and that it's going to take me a long time to rebuttal. I'm taking notes on all these different things you're throwing out there, and there's a lot.
Let me cover GPS, and then we can talk about whatever.
Okay, all right. GPS is another one.
GPS is another system that we use as pilots to navigate the Earth, and this is probably the most common one, the easiest to use. And this is a really old JPL GIF of GPS, but it still holds up, and this is still how it works. We still have the same satellites for the most part as we've had before. So the GPS satellites fly in their orbits, and they have a network around the globe Earth. If you're sitting on the surface, you're going to be constantly connecting to different satellites. And you need at least 4 to give you an accurate position. 3 satellites tell you your location, and the 4th one gives you your altitude above sea level. And you're constantly connecting to different satellites. There would be no reason to have this amount of satellites on a flat Earth. You would need like 2. Reason being, if you're a satellite, let me see if I can do this with grace. If you're a satellite, well, this is not going as easily as I thought it would. Here, let me roll it from this direction. Ah, there we go. All right, if we pretend this is a nice symmetrical cone, your satellite is going to have a certain view of the Earth, like that.
I'm not seeing
as the satellite orbits around the Earth, it's only going to be able to see a certain area.
Yeah, I don't see the video you're demonstrating.
Oh.
I can actually only see myself right now. I don't know if that's...
All right, well, I'm still here. Joseph's here, but he's turned his mic off.
Can you
Turn your mic off.
I don't see anyone else's video. Yeah, I only see like...
We're all still here. I don't know why you don't see us.
Yeah.
With
the opening, why don't we let Josh give a rebuttal and kind of get him looped in?
Sure.
You covered a lot of ground, and it's excellent information. So I feel like,
but it's a lot of information. I definitely understand that.
But I want to see what his rebuttal will be.
Sure.
Just from, Go ahead, Mr. Josh.
And I'm sorry I can't see you guys. If you can see me, at least we can get a good video out there.
We can see you. I don't know what's happened your end, but yeah, we can hear you and see you.
Yeah, so that's fine. I mean, and I'm sorry I really am sorry to interrupt. I mean, I want at times, when the guest is speaking, I want to make sure to I'm actually been taking notes on his positions and his perspectives, because I've heard I've heard all of these points before. None of this is new information to me. None of this is something I haven't heard already. But he's been going really, really. I mean, I've got right here stars, geographic center versus magnetic center. Geographic center is also known as true north. Then we've got compasses. Magnetic center moves. We got
just
gyros.
Pick one and tell us your point of view of them.
Okay, I mean and I'll finish because I want to touch all the only ones I've circled. Right? Compass, GPS, orbit, and then flight paths that's an entirely different topic, and I think I have a couple of quick ones. I mean I'd like to have some questions for him as well, because
you can ask away. You can ask whatever you want.
All right. So magnetic north, I would agree, goes around, and I think the magnetic pole is based on the atmosphere that is rotating above us over the flat Earth. Just for Stephen, correct? Stephen?
We can't hear. Well, I can't hear.
Sorry. Yes.
Okay, yeah. So I mean, just for your sake, just so that you understand the perspective I'm coming from, the flat Earth model that I propose and that I'm a proponent of is like a snow globe with the North Pole is in the middle. Now we're going to talk about North Pole because, you brought up magnetic north versus true north, and that there is a magnetic north and a true north in the flat Earth model, correct? So the Magnetic north in the flat Earth model would be that randomly kind of slowly it moves a little bit this way and that way and ebbs and flows with the atmosphere type of magnetic north. Because perhaps, and I don't claim to explain all of it, I can't tell you at all how the northern lights work, but they're beautiful. But I do believe that there's some kind of electromagnetic phenomenon going on that causes things like the sun, star, and moon, which are all inside of that dome enclosed system, moving above us. And that center of that moving mass would be what I would consider the magnetic north. And the compass points directly north at all times. And so west would be a clockwise motion following the path of the sun and moon and stars. And east would be the opposite direction around that disc-shaped flat Earth model. And south would be actually any direction. So here's an interesting fact about our flat Earth model. If you go perfectly straight in a straight line, no matter where you are on the Earth, you will always end up in the south. And that's a weird one. And I'll say it again, just so it gets there. If you're on that flat Earth model, no matter where you are, if you go in a straight line, you'll always end up hitting Antarctica, which is that outer rim, that circle. And so that's where south is. Anyway, so I move to the next point. I explain with compasses. I explained the magnetic north and true north. True north is just that geographic center that is directly above the North Star, which does not move in the sky. So the magnetic north moves around with how the different celestial bodies are rotating. And then I get a warning that my battery's low. So in the next break, I'm going to go make sure to plug in this device so we don't get cut. We've spent enough energy trying to make this work. But now there's other maps. I want to make sure you got that. Gyros, I don't understand how a gyroscope would work on a plane if it's a non-mechanical gyroscope. The gyroscopes are not affected by gravity. That's why if you're in outer space, you spin a gyroscope, there's supposed to be that like ether. And now we're talking about this really fancy thing where, it's going to move and it's always going to stay in line with that ether. And so if you're going around the globe like this and you start here and you get around the globe, it's going to start to look like it's still perpendicular with where you started, but that gyroscope would look to turn back towards you as you are flying down and around the curve. And it seems that the only gyroscopes that do that are the $20,000 or $40,000 electric gyroscopes. So, ones that can add in the rules of the video game that they want to have if it is supposedly a globe. So all these things that, compasses, where you're going, and flight paths. I mean, there was a flight that was supposed to go from Hawaii, like down to some like random spot down like southern Mexico or something like that. And they were halfway there and some lady had to have a baby and they stopped the flight and they were in Alaska. And on a globe, it was like, whoa, why are you way the heck up north here? But if you turn that onto the flat Earth top down, even the equidistant model that has the North Pole in the middle and all the continents around it, it was a straight line, right? So even the things like outer space, the spaceships that are apparently satellites that use GPS for us. Well, there are also, because there's another thing we brought up, there's these high altitude balloons that when they can see the ground, they can stabilize their flight and stay in one freaking spot and just move slow or just stand there. And they're not like they're visible. They're so far up, like a speck, we could barely ever see them. It's not like they have lights on them. It's a high altitude thing. You need a little computer. They send them up all over the place. And they're basically sitting there on the top like a balloon in your bedroom after a birthday party, measuring where the hell you are on the thing. And it's not that hard to figure out that you even said we only need 2 of them, not 4 if we're on a globe to make all these. And it's rotating, and they're somehow rotating through space, but we don't see their shadows in front of the moon. And there's all these things that you come up with that not necessarily you. I think these are things that I hear all the time, but no one's ever heard what I'm trying to say about it. Really, not nobody, but people usually haven't heard that. And you're always coming at it from, well, since we know it's a globe, then this is how we explain it. And so we know that it has to be an assumption that it's round. And so therefore, all these things. And you get into and you can go rabbit trail on any one of these topics. And I've had spent a really long time with people on just one of these topics, trying to help them just to get their mind around how can you play my video game for a minute and at least admit that I have a valid explanation for how this could work on a flat Earth model, let alone get somebody to change their mind. I don't expect anybody to change their mind. I'm here to let people at least understand why I'm not just taking this on faith and why there is scientific and verifiable, repeatable documents. And as you fly, no matter how high you go, it's flat, it's eye level, it's right up there. But even the globe model has it work that way, because if you look down, you have to go really, really high before you kind of start to see the globe beneath you. So, and planes don't go that high.
I have to ask, do you know how the horizon works?
Me?
Yeah. Either I'll get your response and then I'll ask Steven the same question. But yeah, you first.
The horizon, and this is one of the things we talked about on the last time, like as you're flying and you accelerate in the plane upward, the horizon is going to be getting further and further and further away from you, but it also stays at your eye level. And as you go up and up and up, you can see more and more and more further away from you. And as you look into that horizon, you're also looking between you and the atmosphere in between you and the horizon that has water droplets in it and requires that, not just after vapor. And I had a really funny, conversation with some old friends where I was like, no, it's water vapor. And they're like, it's droplets. We were so like, no. And then we looked and saw it. It was like, oh, it's vapor and droplets. Oh, we were both wrong on that one. And then we learned something, right? So it was a cool experience there. But as you're looking through those to the horizon, the further up you go, the further out you can see, and the horizon starts to blur and blend and kind of mirage back into itself. And it depends on how high up you are and what type of atmosphere and environment you're in. If it's a desert, you might be able to see further. So the horizon is kind of a mirage, and so this mirage has this magical mysticism with it, and that's why we're able to start talking about things that are farther away than we can see.
So are you telling me like the same kind of magic mirage, like a Harry Potter comparison, or like is it a mirage like you think
that the mirage has a perfectly valid explanation, but not everybody in all of history knew how that worked, right? And so sometimes they're like, oh, I saw something and it looked like water, and now you have my phone almost dying, and I think so. Let me just grab that phone charger.
You have given the explanation about the horizon. I'm gonna pass it to Steven, let him kind of give his explanation of the horizon. Because like I said, I'm not a scientist. I don't know really jack shit about science. I know John doesn't either. He drew pictures of phallus-shaped objects in science class, so I'm gonna pass it to Steven. He's got a couple years experience dealing with altitude, dealing with the horizon. He can better explain, but he can give another definition of the horizon in his aspect.
So the short answer is the Earth gets in the way.
How so?
So if we're trying to,
before it gets in the way.
I'm sorry?
How far away is it before he starts getting in the way?
It depends on how high you are.
Absolutely. But what about when you're at ocean level looking over an ocean? How far till it starts getting in the way?
I don't know, 4 or 5 miles.
You can see stuff that's way further, like hundreds of miles away. So how can you see it? If you can,
hundreds of miles, no.
Yeah, hundreds of miles. People have taken pictures of lighthouses that are hundreds of miles away at ocean level from a boat.
Is there actual evidence of these actual photos where you know exactly where the photographer was at the time?
And I might interject, other than lighthouses and stuff like that, can you give a certain landmark or something other than the skyline of Chicago or something of that nature? Can you give an example?
Yeah, I can. I do. Okay. The skyline of Chicago is my favorite one. But I go to somebody else for that information that has it memorized and has done that research of here's photos of this from this far, this from this far, and people do it all over the place, right? So I would encourage you to go show me some of them because they should be easy to find. If they're not, then I don't know. But Chicago skyline alone is my favorite one. That's the only one I have memorized. I would have to get my other phone out or go on and like scroll through to find the resource I have. That's not one of the things, but I mean, there's mountains that can be seen from really far away that we shouldn't be able to see, even based on the elevation and things. And you can see not just the very tip coming over that curve, but you can see like the entire thing. You can see
Okay, so my answer with that is obviously the higher it is, the further you'll be able to see it away from.
So back to the horizon, I understand.
The higher you are, the further you will be able to see. The discrepancy is going to be in something called atmospheric lensing. And I heard this in the last episode that you used, but you used it incorrectly.
How so?
Atmospheric lensing refers to as it would dip. So atmospheric lensing basically says this thing is below the horizon, but we can still see it. Why would we be able to see it if it's below the horizon?
Is that a superior mirage?
I'm sorry?
Wouldn't that be a superior mirage?
I'm not sure what that is.
The superior mirage is the explanation scientists give for when we can see something that's behind the horizon, but we can still see it because it reflects up off of a layer of humidity in the atmosphere and then we get back down around the curve to our eye, but that actually causes that image to be flipped upside down. That was the explanation given for why we can't see Chicago across Lake Michigan. But it's been proven not to be a superior mirage. It's a repeatable experiment, and you can still see it. So,
well, I don't have the data in front of me, so I can't argue that.
Let's explain why light bends down, and you'll say that light bends up and around the curve. I will say that it bends down and out of sight, and so it actually works to be used and explained in both models. I understand how atmospheric lensing works in the globe model as well. I've studied that. I understand that. I'm not ignorant to that, right? So
okay, well then that argument is thrown out then. Both sides.
So,
yeah, that's the point.
That being said, we're gonna skip into a hard-hitting question that I feel kind of matches this, but will take us in kind of a different curve for this topic and conversation. Since there's really no compromise on the debate between flat Earth being flat and the global view being globe, besides hard-hitting facts and, getting down into the science aspect, wouldn't it be fair to say that the whole debate regarding flat Earth is a conspiracy theory?
I'm not sure who would have that motivation either way.
I mean,
you're right, but
that's what makes it a conspiracy theory. Because you don't know who have that motivation. The biggest thing about a conspiracy theory is the thought of who could possibly do that and why is so absurd on almost every conspiracy theory. It's like, that's so ridiculous. And then you turn around and you're like, how could people even think that? And then the next step is, why do people think that? Which is, I think, where we're at in this conversation. And then how could they ever think that was true? Which means rabbit trail, rabbit trail, rabbit trail. And suddenly you're like, oh my gosh, there are reasons. And a conspiracy could be there. And so it allows your subconscious is like, what if I have been lied to? How can I really know? And so then you get in all these rabbit trails and it's just a mess and you forget what the heck you even started it with. And then you just go to sleep.
So we hit this point in the first episode. The whole idea behind a conspiracy theory is just being intrigued so deeply by each rabbit hole to where you eventually lose track. It becomes like a yearn for the hunt rather than facing everything that you have to offer facts. I mean, that's just what I get from it.
Yeah, I said sometimes the rabbit gets away, and you just got to get back to where you started, which is like, okay, what started this one? And it's like, well, couldn't it be a conspiracy theory? And he goes, why would anybody, Steve, you asked the question, why would anybody think that, not alone think that, but why would they trick people into thinking that? And I actually sent Joe some memes on some of those, and there's some silly memes out there, and I don't build my belief off memes or anything, but there you go. There's some interesting things, and there's some interesting pictures and depictions. And if evolutionists can draw and make clay models of fake half monkey human hybrids to try and find a missing link, then we sure as hell can draw some ideas of what we think the Earth might actually look like, and some explanations and scientific reasonings. I even got one on over on the back of this somewhere where I drew a little. Oh, here, look, there's a sunset and what it kind of looks like. I mean, it's a fun debate. It's a fun debate. It's tiresome. There's so many back and forth. I mean,
that being said, I'm going to pass it to Steven and or John if he wants to interject. But yeah, I'm going to pass it to Steven and let Steven roll with it for a minute. And then
I just want to ask one quick question. I just want to know why flat earthers don't know what's underneath the dome. Is it because they haven't made a YouTube channel about it yet?
No, it's because nobody knows. There was this group that went on.
See, that's what gets me about flat earthers. They can't explain things, but yet Globers can.
But that's okay to not be able to explain everything, and even the Globers can't explain everything.
Yeah, but they can explain what's underneath the Earth.
Well, but have they actually seen it, and have they actually observed it?
Loads of photos
no,
of
they
it.
haven't.
Oh, we're back to NASA, and you can't believe. See, the thing.
No, not NASA this time. There's this group that went out and they drilled. Just look up deepest hole ever dug on Earth.
Say that again. I can't hear you breaking up.
Just anywhere you want, look up deepest hole ever dug on Earth. Like, we've never gone down below the Earth's crust to check.
Yeah, but do you think that's because? Do you think that's because it's only a flat Earth, or because we haven't actually been able to come up with the technology to keep drilling all the way down to the center of the Earth?
If I can.
Yeah, go
on. As we dig down, two things happen. Temperature increases exponentially. Pressure increases exponentially. Why would that happen on a flat surface?
Not necessarily, because the observable fact is when you go down that deep, you get more and more water. And then they hit something that was so hard that they couldn't keep going down any further. It kept killing.
It's not about hard.
No. The point, that's what happened. It's not about what it should be. It's about what happened in the deepest hole that ever was dug on the Earth. They got all the way down and they hit something, and their drill stopped going down. They couldn't get it to go any further down. And it hit something so hard that even their diamond drill bits were breaking. And they're like, what the heck is, and they just quit after like months and months. They got through like multi-millimeters further deep. And no one's ever gotten below that. But even the x-rays, and when you dig deep, it's all water down there. And I actually do believe I know what's under the flat Earth, but I'll answer that if you want me to.
Okay, well, let me start with the fact that
I'm interested to find out what underneath the flat Earth is.
Sure.
I am too. Let me start with the fact that it hit something and stopped. It's not about the fact that it hit something harder. It's the fact that as it goes down, there's more and more force being pushed in on that drill bit from every direction. So it's not that it's hard, it's just that the pressure is so high on that drill bit that it can't turn.
Not only that, you have to factor.
They didn't say their drill bit couldn't turn. They said that their drill bit was turning and turning and grinding and grinding, and they still kept going. It was like they hit something really hard at the bottom, and no matter how much it kept turning, it kept coming back. Like I wasn't there. That's what they saw. That's the best physical evidence I've seen for what there is when you dig deep down. and then you apparently you hit something. And I think also if you go straight up, apparently you'll hit something, the firmament, like, and then if you go straight south in any direction or west, straight line or whatever until you hit south in Antarctica, I believe you'll hit the dome and then you'll drill into it and you'll get there and you'll hit something that's so hard you're like, what the heck is this? And it's beyond our physical comprehension, because I think we have, I mean, I do believe in the Bible. I believe that God made this little fancy, cute terrarium dome thing we're living in. And that's just the flat earth view that I have. But you have to take both on faith. You have to take both on faith, because what you're telling me is this is all there because it's curved and the gravity's pushing on it and all these things pushing down on it. And it didn't just hit something. I mean, even though that's what they said happened, and they were able to measure how much further into it they got, and it was still drilling and turning, even though you claimed it couldn't turn anymore. And I like, so it gets a little suspicious. Sorry.
Well, I mean,
under it is water.
What happens when you get to the outside of the dome?
I think it's all water out there.
All water. So we're like, kind of
the
like
Bible says there's water above and water below. So how do you see what's outside of your verifiable realm?
Yeah, but don't they mean water above, as in rain, the moisture in the clouds, and water beneath? You know, because we get water from underground and we get the ocean. So how did you get to the conclusion where there's water surrounding us and we're in one big aquarium?
Well, I would start with, I had no idea to start. I had no idea in the beginning. Where in the heck where are we? What's outside of that dome? Because you already know, I think the sun, moon, stars, and all of that are inside of the blue dome that we live in, and that underneath it, another question, no, we're not floating on a turtle. I think there might be, like, I had this really cool theory about it one time where it's like, it says pillars that were standing on four corners. Well, maybe that's just the four magnetic or the magnetic angles and everything where it is locked in the ether, and those are just, it's locked, like the same when you see those frozen ice things and the whole thing's just locked and we're just in it, and it's infinitely high above and infinitely low below, full of water, infinite amount of water, and that's not even enough to dunk God underneath it. And that's a cool little theory, but the Bible does say there's water above, there's water below, and according to my theory, if we're trapped inside of this dome that we can't get out of by either shooting too high or drilling too south or digging too deep, and we're stuck no matter what we do, then the only way to find out what's outside of it is to commune or conversate with whoever is outside of it, if there is someone outside of it. And I think the only people that can go in and out of that firmament and through it are angels and God himself, and that's where I stand on the whole matter.
I'm just, sorry, I'm just curious about one more other question. The stars, does the stars move, or is it the dome? Are these stars stuck to the dome and it's the dome moving? What's going on with the stars, because they clearly move?
Yeah, that's a fantastic question, and I don't know the answer to that one, actually. I don't know whether it's the firmament itself, like the whole dome is going like this, which could be really cool to think about. And maybe, let me just speculate, because this is one of the things you have to do with this, is kind of speculate, because I have convinced myself, you may say, that it's totally flat, it has to be. So if then there has to be an answer for everything else. So maybe this whole thing is rotating, and that's where all the normal stars are stuck to it still. But the wandering stars, also modernly known as planets, are on their own courses, because there is, and look into it, the planets used to be known as wandering stars because there's only a limited number of them, wandering stars, and they're in the atmosphere, and they move at a different rate than the whole rest of the stars all together. And obviously Polaris is up here at the top, like a top of a fancy chandelier, and they're all moving. So I have thought, and are the lights actually shining from a source but then being lit up inside of the atmosphere? And so is the light, or the source of the energy from the light, coming from outside of the dome? That could explain a few things. So now you have to get into, and I've only been at it for 7 years, and there's so much debate and confusion, and I think there's a lot of forgotten knowledge because most people don't even know what an astrolabe is, let alone how to use one to measure the stars and where they are and where you are in the world. And so we're losing some of these parts of our educational system, and we're losing the ability to even understand the sky and how it works, let alone not just observably, but how does it work according to a globe model and according to a flat Earth model? Because this is a debate that has existed ever since both models existed, and it's been going on the entire time, and the debate hasn't gone away.
In the scientific community, there is no debate.
The
and
modern
there hasn't been for 500 years.
There still is a debate in this community too. It's just that most of the people who are flat Earth proponents admit to shutting up their mouths because they don't want to lose their job, or they, there's people, there's polls. I don't know. Hey, some people don't talk about it. But in ancient times, there was all kinds of people back and forth about flat Earth versus globe.
Before we discovered the mathematics and technology that shed light on it, yeah.
Mathematics and technology are a modern phenomenon. We've had mathematics and technology since the pyramids were, and the pyramids are based on the stars and the angle of them and all this kind of stuff. And there's all kinds of stuff that lines up that we've known all this all along, and the debate's still been there.
I'm not talking about astronomy. I'm talking about physics.
About astronomy right now, but I'm talking about flat Earth and how astronomy works towards it. And it assumes that astronomy doesn't work on a flat Earth model, and it totally does.
I'm not talking about astronomy because that's just observing stars. Physics.
To make sure that I'm following correctly, based on what we've just heard, from a flat Earth aspect, the Earth is under a dome, allegedly surrounded by water, with a baby mobile, the little rotating things with planets.
Oh, the stars, yeah, going around like a baby mobile, because we're all, it's like a womb, and God's getting ready to birth us all into eternity, I think, and everybody makes it. But
for that to work prospectively and be to cover the dome, so to speak, you would have to have it on something that constantly moved. It being above or around, you would have to have something that drops down over said dome and rotates just like a baby mobile would. It's not like trying to make it.
Yeah,
it's not making it. It's simplifying it to make sure to give you a picture in your, like a mental picture for simplest explanation terms. Yeah. We're in a dome surrounded by water with the stars on a spinning object above the dome.
Or maybe a better explanation is that the dome is what's spinning. Here, sorry, I got a rain outside being some background noise here. Beautiful rain coming down. That's nice. Yeah, no, totally would be. And I, like I said, I don't know whether it's the stars moving or if there's a light source above that moving or if it's the actual dome. I think it's probably the whole firmament moving, but I don't know how that would work. So there's only so many things that there are explanations for. It's cool that the explanations always end up going like this one, what's below the Earth? Well, the best explanation we have right now, if it's flat, is what the Bible said, that there's water under there and water above it. There's a lot of different topics.
Sorry, Joe. Can I just quickly something?
I'm getting all off topic.
Sorry, can I just quickly just say something?
I want to get this back on track.
John, go ahead.
You class yourself as a biblical flat earther. So where in the Bible does it say? Oh yeah, before I even get into that, what shape do you think this flat Earth is? Do you believe it's a disc?
Pretty much, yeah.
Right. So with you being a biblical flat earther, you would know that in the Bible it describes the Earth as square.
So okay, and yeah, I do. I know that.
So where's the disc come from? Even in the Bible, it says square. It says it refers to four corners of the Earth Quite a few times.
Yes. So I have an answer for that fits my model. Essentially, and you have to like, this is what cognitive dissonance does. You have to be like, wow, does that fit my worldview on the model? That's a weird info. If that's true, then my whole thing could be screwed up. You have to check it all, right? Like what you tried to do with me. But I've heard square and circle Bible. I think that Antarctica is based, and the sun and stars all move in a perfect circle, right? And that the Antarctica is probably around it in a circular shape, but that the Earth, the land masses, have 4 separate corners. And if you go look at the equidistant map, or if you don't know what that is, look up the UN logo. The logo they use for the UN, they use that equidistant top down with the North Pole in the middle model. And you can draw, it's not a square because it doesn't say that in the Bible it's a square. So
it says 4 corners. I've never seen corners on a disc or even a sphere.
Hold on. I'm talking about the land masses. So I'll pull up a little blank sheet of paper and I'll show you. Oh, this is going to be ugly. Okay. But I'll draw as big as I can, as quick as I can. We've got a North Pole in the middle, and here's America, and here's Europe, and here's Africa, and then here's Asia and Australia. Yay, okay. So, okay, there's the little flat, and maybe you draw a little picture one, and it's a circle all the way around it, but on this piece of paper, there's 4 geographical farthest distances away. So maybe it's not a square, maybe it's a rectangle that has 4 corners, but it encloses the land masses. And so the Earth, because nobody's really living in Antarctica on the circle.
I thought there were military bases, so they must have houses there.
Oh, sure. Maybe the corner just got extended a little further, and now, it's got corner. But at the same time, can't the Bible have a little bit of metaphor? Because you guys want to say I'm an ultra literalist. No, I don't take everything in the Bible literal. We got some pulled up, right? So there's 1, 2, maybe 3, but then you got Hawaii over here. So 4 general. How many? Oh, it looks like
if you counted those corners, there's actually 6 there. There's not 4.
Oh, it looks like I was gonna say, but it looks like they cut it up into
2, 3, 4.
Isn't this 8 corners? So can't we divide that by 2 and call it 4?
What if the 8?
Based on that,
got 8 pizza slices there, which is making me hungry. What if we just cut it into 4 so I know I'm gonna get 4 corners?
Based on that, though,
you're trying to fit your own.
I mean, no
theory of it. You're cutting out pieces. Well, just pretend there's 4 there.
With 8 corners. That right there looks to me like a circle with 8 corners in it. But I want a bigger piece of pizza. I want you to cut it in 4s and give me a circle with 4.
You're the one that brought up this symbol, so we're using it as an example. I didn't.
And I'm mocking your example because your example shows a circle with 8 corners. So that also has 4 corners in it too. If you turn your corners upside down, you're looking for your corners in the wrong spot.
Well, this is your example. This is the UN logo.
Well, yeah, but I just was talking about this is what the equidistant map looks like.
Well, yeah, there's
okay.
More than 4 corners there, though. You've just
picked
now
an example. The model picture, like you guys got to keep up with my humor here. Like I've got a circle in front of me that has 8 pizza slices. Now, if you take 1 pizza slice, how many corners? 3 now. Well, my whole point that I'm making is corners of the earth in the Bible. It says 4 corners. You don't have to have 4 corners that are in a perfect square, saying that the earth has to be a square map. It can fit, you can have, because another verse says that the Bible is that the earth is like wax beneath the seal, or clay beneath the seal, that ring. And I sent a little meme or a picture of that in Messenger to you there. And that shows that a seal.
Sorry, which one was that? And I'll put it on the screen.
Yeah, tell me where. That's what I want to know.
Which one were you
personally.
talking about? Which picture?
There's a one that says a Bible verse, and then it shows a little like wax seal thing with an imprint into it from a
Oh,
flat
right, yeah,
Earth
hang on a minute.
map.
I'll have to get that back off you. You carry on talking and I'll bring it up.
Okay, well, I mean, essentially, what I'm saying is the Bible doesn't contradict itself by saying that it's circular, and then in another place also saying that the Earth has four corners. What if I take that word? Because look, what if the word corners in that context just is referring to quadrants? I mean, we already have continents, and so we don't. You need to understand the context of understanding four corners because maybe that four corners of the world just means from north, south, east, and west, no matter which direction you are. So that can simply be a phrase that was used that explains no matter where you go on the earth, you're always going to gather you back from the four corners. Right?
If I can interject,
it also says circle in the circle of the earth in other verses. So
we let
now we're describing the earth as literally describing the landscape of the earth as a circle, whereas the other one is more talking metaphorically, I'll gather you in from the four corners. So I mean that's how you can circle, square. Go ahead.
We're gonna change speed, Stephen. Go ahead and give your response.
Well, I just was going to say that I'm not a huge fan of using the Bible to describe our physical world.
Sure.
Because, I mean, you can, whether you're religious or not, the Bible was written by people. You could say they had a certain inspiration or whatever, but it was written by people with a certain perspective, with a certain culture, and different cultures could have had a different perspective. When it comes to the explanation of the physical world, it doesn't matter what opinion you have. It's, hey, let's look at the data, see what they say, look at equations, see how they are able to explain things, or whether they're not able to explain things. And just one thing I want to touch on about the astronomy thing is that Newton and I believe Kepler, if I have my scientists' names correctly. Anyway, the equations that whichever one it was, okay, it was Newton that used Kepler's equations. So Kepler made these equations that explained the way the stars moved in the sky. And they worked great.
Before I forget on that, I mean, he's basing his theory off of what the other guy said and assuming that what he said was right. But if what he said was wrong, the math might still work to prove his model on a globe, but that doesn't necessarily, if you go all the way back in the original model you're using of assuming it's a ball, which goes back to opinion versus data, because if you have your data and you're approaching that assuming, well, how does this data work on a ball Earth model? Then you're just arguing the rules of a video game, in my opinion. And how does it work on a flat Earth model is never even considered.
Okay, but Kepler, who came up with these equations, was a geocentrist and a flat earther at the time. And he came up with these equations that explained how the stars, and he could predict where the stars would be at certain points with his equations. Sure. Newton used those equations to describe gravity.
But the equation.
Hang on. One more thing.
Yeah, hold on.
I'm curious to hear this point, actually. Go ahead, Stephen.
Well, and then I want to say about 300 years later, armies used those same equations that Newton came up with to hit targets with a ballista, which shot balls of iron or steel, whatever, through the atmosphere.
Yes. The equations are basic physics, right? I mean, and so basic physics works just fine to describe how quickly objects fall. What you're describing is not the theory of relativity, but the equation which describes the downward acceleration, which people then call gravity, which people then come up with not how does it happen, which is what what all these equations are based, because all these equations are simply just equations to describe how to mathematically measure and predict what actually happens when I drop a ball. You can see that goes at a downward force. Now, so you guys can call it gravity all you want. I'm going to call it electromagnetism. We can agree that it's a downward force. But the mathematics to describe that downward force is still exactly the same. And you're saying, so you base all your stuff you think of about science on someone who thought it was flat Earth, and their science works just fine in both models. So, I mean,
Right, so
that's what I was saying.
Say electrical magnetic forces keep people to the ground, right? Well,
it's not just electromagnetism. There's all a multitude. We touched on that last time. There's more than one thing that determines how quickly you go down. And
yeah, you said density, which isn't a force to start off with. It's just a measurement.
Yeah, but mass goes into downward acceleration, does it not?
So let me ask this very, very important question then, considering you touched on magnetism. If we're all being held down by magnets, could you explain?
I've got a feeling you're going to make the same point I was just about to. Go on.
Yeah. Why would we have military weapons such as the electromagnetic pulse that shut down every bit of electricity within such a mile radius?
And also, they're being held down by magnets, right? Magnets hold down metal. They stick to metal. So why aren't we seeing loads of people? Hang on a minute. Why aren't we seeing loads of people with metal hips and metal?
It's not a magnet. It's not a magnet.
It's not a magnet now. You just said it was magnetism.
No, magnetism and electromagnetism are two completely different.
No, they're not. They're the same.
Incorrect.
They're the same thing.
They're not two different things. They're the same thing.
Electromagnetism is something that occurs is holding together the atoms inside of molecules, and what's holding those electrodes and the positive, all these forces. And frankly, if it is similar to a giant magnet, then wouldn't that be just a simple explanation that
no, because metal and anything metal will just stick to it.
Well, it doesn't stick to it because you can
So using electrical magnetism. I'm getting muddled up now.
Let's just assume it is a magnet for a second. Okay, let's go with that theory, because maybe it is, for all I know. What if it is a giant magnet we're standing on, and we're like this magnetic, and we have a north and south pole inside of our bodies, and chakras, and let's just go with it. But I do think it could be a magnet. Who knows? Well, I can still hold something onto a magnet and pull it back with my strength of my body, but it will feel heavy and be pulled against that magnet, So, I mean, that would be a simple explanation for.
In your credit, electromagnetic forces as well as gravity diminish exponentially with distance.
Right. So if you go up
they
higher,
diminish the same way.
You fall a little slower as you get to the top, for all I know. I don't know. I haven't been up that high. But at the same time, we are electrically charged, and electricity has a hell of a lot to do with magnetism. And there was this guy out there who was like, hey, I think it might have been Tesla, that says the only force you have to counter is the electromagnetic force, and you can make a freaking steel ball rocket up at the roof. And it's like, whoop, there it goes. Because it's So there's all these things that I think that electricity and magnetism. I am not a college student of these topics. I want to know how these things work. I want to know why Tesla claimed to have unlimited energy and all this. But all this goes into the explanation that there's a hell of a lot more going on than just downward force has to be defined as gravity.
Right. So with a magnet, objects with the same charge produce a repulsive force. Right. Magnets have two. You think about a horseshoe, right? So what charge are we then? Why aren't we really sticking to the ground or being repelled? And why aren't other things being repelled? Anything that's the same electrical charge as the Earth?
I'm gonna add to that. And I'm gonna add to that. And if it's a magnet, and you spin it, it has to be spherical to spin it. And if you
Well,
spin
what
it,
about
then
a circular magnet? You have those all the
the
time. That's
magnetic
what's
pole.
inside of those little, you know, there's more than one magnet out there. You see what I'm saying? And some of them have a North Pole and South Pole. Maybe we're a vertical magnet, and the top of me is red, and the bottom of me is blue. I just so happen to be wearing blue shorts and a red shirt. You know, like, and that's what determines which way is up and down, and my blood flow, and it just so happens to know how to spread that out. I mean, it's pretty amazing the type of things that go on inside of the human body. But on top of that, there are circular magnets, like what you use if you have one of those little things that picks up nails in your yard. If you turn it upside down, the magnet it's like the shape of a tire. It's round and there's a hole in the middle of it, right? And I've actually seen people that say there's an experiment where you can use a magnet like that and put it in between two copper coils and use it to light up a light bulb without the magnet actually touching the light bulb. And I've seen a nonstop video of it. I'm like, that sounds cool. And I tried it with my son, but I broke the whole thing and it didn't work right. But I still want to try again, see if I can get it to work. It just took me like a really long time. I'm like, oh, try again. They broke. So we
So
got lots
to
to do anything. But anyway, my
the
point is
question,
magnets
to
can
put my
work.
question back into effect, if we are allegedly being held by magnets,
Yeah.
what would be the use of weapons such as the EMP or other weapons that are specifically designed against that sort of thing?
Well, for all I know, maybe those are doing damage to our environment. And, you know, I don't know. Like, they could still work. It's the way it goes. But tell me, why don't you do an experiment and see what happens when you fire one of those over a circular magnet? You know, I don't want to know what happens if you demagnetize the Earth and the sun, the moon stops spinning.
You think we might float away?
No, I just think everything would go dark and God's going to have to intervene. And it's kind of
From an EMP?
no, from a biblical perspective of, hey, we're all screwing everything up. Plus, the Earth we live in right now has a limited amount of time that we can live in it. And things are already decaying. Animals are going extinct.
That's straying away from my original question, though.
Anyway, yeah, no, I'm sorry. It's just there's goes a lot. It's all in. It's all tied together. It's all confusing. You get really lost on it. You know, your question you ask is so complicated to answer sometimes that it's like you have to understand it.
How so? I think we've asked several questions regarding the topic and the information that we're trying to perceive. We're just trying to ask factual questions to get more clear ideas and answers.
Right. State your current question for me on this one. Because I've got a lot of things that I feel like that's what's so long and I talk too much and all this that there's so many different topics I don't even feel like we could ever even have time to get to where I could give you what the explanation is to each of the questions. I mean, I've got 1, 2, 3, 4, 5, 6, 17 different. Anyway, but your current
one thing, can I add, Joe?
Yeah, definitely, Steven.
Have you ever heard of? Oh man, I'm gonna forget the name of this. Occam's razor.
Yeah, but I would need refreshing on this.
I think that's how you say it. Occam's razor.
Yeah.
Occam was an English Franciscan friar, so Christian, whatever, theologian. I don't think religion has anything to do with this, by the way. But anyway, Occam's razor is the phenomena where usually, and this is just a rule of thumb, usually the simpler answer is the right answer.
Right.
So when you have to explain your theory in this 5-minute thing instead of a 2-second, this is how it works,
I'd like you to
the average person is going to be like, whoa. There's another professor somewhere out there that said if you can't explain the thing you're talking about in less than a minute, then you don't know that answer.
See, I've always liked Judge Judy's one. If it doesn't make sense, it's not true.
Mm-hmm. It's not true.
It goes back to my. I mean, Stephen can answer this for me. You flying an airplane that has a lot to do with electronics, pull, drag, lift, the whole 9 yards. Why would I don't feel the need if you're going to have that much risk as far as population, equipment, airplanes, why would you have a need for a weapon like that? See what I mean? Kind of goes hand in hand.
I don't want to know any of that. I don't want to, I don't care about any of the military weapons or why they're doing what they're doing. I mean, they got their own reasons for all that, but when you get back to all of these things, even it's the simplest thing is the simplest explanation. Like, yeah, I do think that the simplest explanation is the flat Earth model, and I do think that I can explain that model and summarize it in 1 minute. I don't think that you can do that for the globe because I have all kinds of questions that I would have to ask that if I was coming solely from the only thing I've ever heard is flat Earth model and I've never heard globe model, then there would be all kinds. I mean, I'd have to have a whole indoctrination to answer all those questions. That's how it all works. So it's not necessarily the simplest model, and there are still things that the globe model doesn't fully explain. Things like black matter don't follow the rules of gravity. So why would you insist that all of the magnetic rules of a magnet inside of electromagnetism, that would have to follow the exact rules? There's all these variables. You see what I'm saying? So, and the simplest model is no longer simple when there's somebody trying to present an alternative. You see what I'm saying? So, especially when you heard the flat Earth model explain to you, and it really can be kind of simple, especially if all I have to say is, hey, there's a lot of reasons I could explain to you why the Bible has to be true, and I can show you the Bible says it's flat, at least in metaphor, but also in general terms without specifically saying it's flat, because that's usually what the Bible does. It doesn't just give you the answer, it gives you everything describing the answer and makes you draw the pinpoint in the middle. I think that the Bible describes the earth as good, and there's flat, and that's a very simple explanation for me, but you have to take it on faith. And then the point is you also have to take some of these globe model things on faith because the ability to verify any of this information is very, very difficult. And the fact that it works in both models is confusing to both sides of the argument.
All right, let's take one easy explanation. Let's take ballistics for an example.
Okay.
I'm not sure how well I'm showing this here.
I can't.
The middle would be our. You can't see this.
No, I've pretty much been looking just only at black screen this whole time.
It's a bit blurry as you bring it close to the camera. I think it's because you've got a blurred background.
Oh, yeah, let's fix that.
No, I don't see anybody. Like I said prior, I only see JTSH and then the logo for Alpha. I see,
Joseph, how did you get all your? Because you're working on a phone as well, aren't you? So can you tell?
I don't see. I don't see the J's. I see our guest.
Right. So
I see the drawing. Zoom out a little bit out to your left. Okay. Yes.
All right. So basically, here we have a spherical Earth.
Yes.
On a flat piece of paper. So we're making this 2D for now, but I think we get the gist here.
Okay.
If we throw something forward, it's going to end up somewhere along this curve, right?
Yes,
if we throw it further, it's going to go further around the sphere. If we throw it further,
Yeah.
We go even further, and eventually, with
Orbit.
enough horizontal velocity, horizontal energy, it's going to go all the way around.
Around in its orbit. Yeah, I know that. And
how would that work on a flat Earth?
I don't understand how that works, sir. I do have to apologize, but that was offensive that you would even think I don't understand that. But the point of this is you don't understand how the flat Earth model works, because a plane that's going 6.7 times the speed of sound at 4,250 miles an hour, 4,250 miles an hour, and it's not having to dip its nose down. You're like, oh, gravity pulls it along the curve. Well, that curve would create a centrifugal force upward, and I called today to try and find somebody better at math than me to figure out what would the centrifugal force be upward in that person's skull to where they would be going, oh my gosh, around this curve, not to mention the fact that they're just going. And the gyroscope in their plane isn't rolling back any faster. It's not like as you go fast, now fast, now fast, and you're going around the curve, it stays flat. The gyroscope doesn't twist and turn along with the ether like it would if there was a curve that it was following. They go straight, and they can go straight, really short, shallow, not that far off of the water. And they're just boom. And all these bullets and stuff, well, a bullet doesn't have a jet projecting it. A projectile just goes, woo, and eventually will drop and hit water. And yes, if you have a projectile on a globe model that goes fast enough, it won't have to curve around and do that. And that's how they explain satellites and all that. But we have our own explanation for satellites, and that orbit is just, going this way and nothing else. Even in the last video, you were talking about these guys going up and doing these adventures into space. You even said, oh, you just scraped the dome, like it was a joke. And I was like, yeah, that's probably what he did.
Yeah, that was Jonathan that said that, we were talking about Richard Branson at the time.
Yeah.
So, yeah, apparently he was just repeating what he's been told by flat earthers. They just claim that he's skipped the surface of the dome.
Right,
Yeah.
but here's the thing. If you want to talk to a flat earther, don't assume they don't understand basic things about what we learned in school about how this stuff works on a globe model. A flat earther has to run through all of that globe model stuff, and you guys want to explain it to us like we don't know what you're talking about. Get past that. Get to the arguments that we're trying to present and how it can actually work in our model.
Yeah, but there's never ever any real evidence whatsoever.
Real evidence.
No, just somebody talking, somebody on YouTube, and even the photos and stuff that you sent me. None of them whatsoever prove flat Earth.
Because I'm not talking about me having to go out and fly a plane at 42.
Yeah, but we've got a pilot, so why aren't you listening to what he says?
I am, but I'm asking him I just asked him the question, what about a plane going Mach 6, which is like way, way, way faster than a commercial plane. And so on a commercial plane, if you were having to dip your nose, maybe you wouldn't feel that upward like you're on a roller coaster. I mean, they have those zero-G planes, right, that can make you feel like you're in zero Gs. Well, at what point is that curve going so fast at 6 times the speed of sound that you're going to feel an upward pull that might even be so heavy that it could black you out? And yes, we hear G forces, but what about at sustained paces going for that long and that far? They're like, oh, you can do 90. So there's all these things that go into it. And then you want to talk about flight paths. Nobody answered why that lady got dropped off in Alaska to have her baby when the flight should have been going over the ocean. It went way out of its way.
Well, I've got no idea what you're actually on about there. If you got some links and stuff, as long as it's not a YouTube bloody video.
No, the thing is, people need to go look this stuff up for themselves. Like I don't have the time.
It's all on YouTube. That's the only place you ever find this stuff.
Oh, it's not. And if you go back, I mean, go look up books like Zetetic Astronomy, and a lot of these people who have done experiments on water where they've floated their boat away and just kept seeing how far can you go and measure how many miles based on the curvature that globalists give you. And these are people who aren't just going to screw up and make the 8 inches per mile squared mismeasurement. And these people know how to do this. And it's like I can't just.
Right, it looks like Stephen wants to say something there. He looks like he's about to jump out of his seat to say something. So,
again,
would you like to jump in there, Stephen? Something. What about this? these jets? Anything that
When we talk about the jets, 1G, you hear that term. 1G is, I'm sure you know, is the acceleration that the Earth is giving downwards, whether it's gravity or electromagnetic forces, whatever it is.
You know, we're getting somewhere.
I'm just, for the sake, devil's advocate here. It's
Sure.
always 1G is what the Earth is pulling at us. They're pulling down, the downward force is 1G. If you were flying fast enough to where you needed more than 1G acceleration to stay at the same altitude, that would be the point where you are exceeding, what is the name? What is the word of this?
Escape velocity.
Yeah, escape velocity. If you're going below escape velocity, gravity is pulling you towards the Earth. So you don't need that centripetal force that you're talking
Gravity
about.
doesn't disappear once you reach escape velocity. Escape velocity is defined by gravity.
Right.
So my point is that in order to maintain altitude, I don't care what, around the ball, you're going to maintain 1G. And in order to maintain 1G, because if you get further away, you're now above 1G. If you're accelerating, so the G forces can change. But if you're maintaining perfect altitude in order so that it's only 1G and you're maintaining 1G force, you have to maintain a constant velocity and a constant altitude. But on a globe,
No, negative.
Well, stick with me here. On a physics program, in order to make that ball, like you're in an airplane, the only reason I can throw this up and catch it is because I'm moving at the same speed and I'm not moving any fast. I'm not accelerating forward. I'm not accelerating backwards. I'm maintaining a constant speed forward in the airplane, right? And then as I'm going on the curve, I have to follow the curve around on a globe model in order to stay at that same thing. But I'm saying if you're going fast enough, in order to follow that curve, you're going to feel a centrifugal force, which is in addition to the gravitational or downward force you would feel. And so you can't measure a centrifugal force going up and around that. There's no upward force, even when you're going 4250 in Mach 0.67 in one of these fancy planes. They're still just holding, and the pilot's just fine, feeling pretty much 1G. But if he tilts up, he's in danger. If he tilts down, he's in danger. He's got to hold that thing freaking perfectly flat. And if he goes too sharp in one way or too sharp, that whole plane's going to freaking explode, and including him into every direction, like they say the universe is acting right now. And he's going to feel it, right? But that
absolutely. But gravity,
like a bullet that has a rocket on it, and it is not dipping down. Because if it dipped down, that wind and all that stuff going around with it, he's curving with it, he would still have to be feeling the centrifugal force upward in his brain, going, oh my gosh, I'm about to pass out. And I want to know, what are the mathematics of how much G force is upward according to the curvature? Centrifugal forces, how much are the centrifugal forces that pilot is experiencing in an upward direction as it tilts its nose down and around the curve?
Gravity is an acceleration. So you're not unaccelerated. Gravity is an acceleration. 9.8 meters per second squared. That's what it is. So it is accelerating you around that curve.
That's fine. But in an airplane going around, downward acceleration that you feel, that's the downward force. That's why you feel heavy. That will stay the same.
You got to let him finish, Josh. Let him finish his point.
If you were going faster than the escape velocity, you would need to accelerate faster than gravity could accelerate. And in that case, you would be correct. But 4,200 miles an hour is not faster than escape velocity.
Josh.
Never said it was.
You can retort.
Yeah.
Josh, go ahead.
Yeah, my bad, you guys. I interrupt really bad, and I talk way too much. It's a fault of mine. I know I have. It's one of my, actually my symptoms. I get racing thoughts and stuff as I coach individual. And so please bear with me through my rudeness, like I said. Storm back there. But please go ahead. Keep a little tighter rein on me.
Well, I'm just saying, if you were going faster than Earth could accelerate you around that curve, then yeah, you would have to input a force downward and accelerate at, say, 2 Gs. But that would be inconceivably fast. That would be like 14,000 miles an hour.
What I'm saying is that a plane going that fast is also going to feel a centrifugal force upward, and the fact that it has to dip its nose down that
1G.
So then it feels zero gravity.
No. If you were going that fast and you were orbiting,
and the Earth is pulling on it with 1G, then the pilot would essentially feel weightless. Well,
that is exactly how an orbit works. Yes.
Well, no,
that's why you feel weightless in an orbit.
Yes, so the plane is doing a perfect orbit and doing 1G. All right.
If you're going exactly the speed that would be required to orbit the Earth at that altitude, yes, you would feel 0G.
Well, that's just a coincidence of the mathematics, or is this how?
No, it's not a coincidence at all. If you go slower than that, you will not be weightless.
But here's what. All right, so you made your point. That's 0G, and so the pilot would be feeling 0G, right? All right, cool. You won that part of the debate. It also works on a flat Earth model, because if he's going perfectly straight over a perfectly flat model without accounting for the curve, he's going straight. Is that pilot feeling weightless, or is he feeling 1G when he's flying? The pilot on a flat Earth
1G and never anything different.
So that's what we feel on an airplane.
Because you're going so slow. If you're going 600 miles an hour or even 4,000 miles an hour, that is a fraction of the speed that you would need to be going if you were orbiting the Earth. If you're orbiting the Earth, I think the space station goes like 17,000 kilometers an hour.
Sure.
Now we're talking.
Have to be going, yeah.
And if you're at a lower altitude, you would have to be going even faster than that. But that's just the geometry.
Well, right. Okay. So, but you're talking about the same type of thing as if it were curved. If it has to be curved, that's what I'm saying. I've almost never okay, help me find something that doesn't work in both models. Because if you
that doesn't work in both models.
Well, on a flat Earth model, if you're going perfectly straight on an airplane, you're going to feel the 1G, and you're telling me that a pilot okay, so then a pilot that's going the 6.7 times the speed of sound would then have to feel weightless. We would have to go up, and in order to experience that for ourselves and know whether you're weightless going that fast around the curve. Or if you're going around the curve, it's exactly the same feeling whether you're on flat or round. But then the question is, what about flight paths that go directly perfectly south? And then I've had that brought up, like, oh, perfectly south. Yeah, there was this Navy plane thing that skirted, and it went from here to here to here to here. And did you hear about this flight? And then you draw the line of that flight path on a globe, and it looks like it goes around the South Pole. But if you draw that flight path on a flat Earth map, it makes the oval, so there's all these things that go back and forth, which is why this is so fascinating for me, because the only way to prove that it doesn't work both ways is to be the pilot yourself in the plane going 6.7 times the speed of sound, and then you would have to say, while you're focusing on all of that, you'd have to say, do I feel weightless or do I feel 1G? Or
you could measure that, and that's the whole point of these.
Right. So
that's the whole point of these Jeff Bezos and all of these guys.
And how do I measure that if I only have a one household income? And how can I trust the multi-million-dollar individuals who have their finger in the amount of money it would take to supposedly measure that, who have been willing to lie in the past about all kinds of things, but can't lie about every little thing, and you've still never addressed why do the gyroscopes not roll backward around the curve and stay with the ether as you turn around that curve, regardless of how many G-forces you feel? And now you're sitting here, and you get into all these different aspects of it. And what you get to the end of a rabbit trail is like what I hope we just did. When you get to the end and you're like, okay, now we moved on to what the next argument is, because neither of us are going to be able to convince each other on this topic. And I think that there's a valid explanation in both models. And so, I'd like to actually move on to a different topic, because there's so many out there. And sure, I'll dig into this as long as you want if you have more questions about it. But I feel like it works well, just fine in both models.
Well, in terms of orbits and acceleration due to gravity, the flat Earth model would not work. Because on a flat Earth, you still there?
Yeah.
Oh.
Go ahead. I just have to just give me a second.
Oh, no problem. I just saw as long as you're still there and listening. On a flat Earth, it doesn't matter how fast you go.
All right. Sorry, I had to step. Got that
No,
part
go
for
ahead,
a second.
Steve.
Go back a second, and
All right.
I'm just great. Sorry.
No problem. On a flat Earth, it doesn't matter how fast you go. You're always going to feel 1g. Downward.
Sure. Yeah.
On a globe Earth, the faster you go, the less effect gravity is going to have on you.
Yeah.
Okay, but we observe the one happening and we don't observe the other one happening.
When do we observe that happening?
That's the reason that spacecraft are able to orbit, because they're going that certain velocity.
Spacecraft, in order to get your supporting evidence for that. Show me the supporting evidence, then you have the burden of proof towards me, because you haven't shown me anything. Prove it. Prove that
you can walk outside and watch the ISS go over.
I just walked into that conversation before, and I think that people who've looked at it with a P900 lens, they say it looks like an airplane dressed up to look like it.
It would be impossible to go that fast.
You can't see it with your naked eye other than a little dot.
It would be impossible to go that fast.
Somebody show me an unedited clip, and you can't, because the only way to do it, you got to go through a P900 lens and zoom all the way up. And people who do that, it looks like a little airplane dressed up.
Well, it's because it's 400 miles straight up.
No, but they can zoom in pretty good on it, and it looks pretty much like an airplane, not what it looks like in the CGI photos that you see. Go look up real, actual photo of space station, and you get so many CGI bullshit pictures of it. Just go show the picture I sent, because you're like, there's no proof. Well, I can at least prove to you that NASA's lying about something, even if it's just lying about the fact that, we'll tell you what it looks like up there, and we're not actually going to go up there. There's a photo of Earth from outer space.
Can I just quickly ask, which photo was it that you sent that you want me to put up?
Photo of Earth from outer space, and the two separate NASA photos of Earth from
ones. Yep. Hang on a minute. I will attempt to. You carry on talking. I'll attempt to put it now.
Really big, and one of them looks really small on North America, but the sphere of it is the same size. And they're like, oh, that's just based on how close and how far you are on the thing. And it's like, well, I don't know. It goes both ways on all these things. Why would NASA be screwing around that much and having so many glitches on their?
Can you see? Has the picture come up yet?
All I see is Skype.
NASA. So then the only one and the only.
About now.
I don't know. Put a couple of them out.
There it is. Oh no, that's not. I don't think that's the one he's talking about.
Oh right.
That's not what I was looking for, but that one's kind of interesting.
Oh, hang on. I think I know which one you mean. Just give us 2 seconds.
Hey, what does it look like when you're flying up there all the time? Do you
that one you're on about?
It's not. It doesn't take a rocket scientist and someone who can explain how a rocket and an airplane works around the curvature. Yeah, I kind of bait into talking all the way deep, and then you get to the end, and the whole point is, hey, it works just fine on both models. But this doesn't work with NASA telling us the truth. Look at the size of North America in 2012 and 1978. Now I know I live in America here, and my friend over there in Europe. I would probably lose the debate if we were talking about who lives in the better country right now. But I do consider myself somewhat of a patriot. But America's not that, it's not getting bigger right now. It's getting smaller, if anything. So geographically, I don't think continents can grow sizes from year to year and change in the size they are. Like, so NASA's lying about something in at least that photo. And then you go look, and you're telling me that the only way you can prove that that curvature of a flight path going that far is if you go into a plane going Mach 6 and Mach 7, then apparently you'll feel 0G like in orbit. I mean, I get it. That's,
Well, to explain those two pictures, it's all geometry. It has nothing to do with space science at all.
geometry. If I put geometry into a computer program of a flat Earth model, geometry still works exactly the same on a flat Earth. It's just numbers and how you find what angle you're at and all this.
That wouldn't make those pictures possible.
This picture would not be possible on a flat Earth. You're correct. I don't think this picture would be possible either of these. Well, one of them would maybe, but not both possible on a globe model. And,
well, they're taken from different altitudes, like you've heard before. From a certain altitude, you're going to be able to see a certain amount of the Earth. From a higher altitude, you'll be able to see more of the Earth.
But they're not. They claim to be taken from different altitudes, but then they admit that they're not. They're a composite of scans taken from far lower altitudes. So, but
well, then they're not one picture. Then you can't make any argument based off of them.
That's the whole point. They can't give us one simple picture of Earth from outer space. And so why fake the shape and size and orientation and all of that? Why just smudge it all? And why can't you just go out there with a P900 and fucking snap it? Use my language. But seriously, like, the other issue is that if you go to the first picture you brought up, you'll see, oh, here's the thing at such and such a feet footage, and now you can't tell what the curvature is wherever you're at because it's either a fisheye or it's not a fisheye lens. And it's always curving, but it's never the same. And then it's curving in a convex way and back and forth. And it becomes all of these weird things where you can't even find consistency from NASA. And so how can you trust an organization giving you facts if they can't even give it to you in a factual way? There was that one back there with the Bible verse that describes the Earth as being like wax beneath the steel. Now, yes, this could be considered metaphorical as well about the ripples in the continents and mountains and all that, but I just think it's a cool little one that puts a Bible verse up there. So sorry, got to give my plugs once in a while. But anyway, that's kind of what I picture the edge of the Earth looking like. Like dirt.
Where was that? Yeah, because you sent it to me, and I was wondering why you'd actually sent it. What was the point of it? So can you just quickly explain what this picture means to you?
I don't have enough money to go straight south until I hit that, and I don't think that's necessarily what it looks like, but it's a cool like visual depiction. I'm pretty sure that this picture was definitely not taken anywhere near Antarctica. But it's a cool little idea as to like, oh, if you were to go all the way out, all the way south, go through all, and there's a rabbit trail you can find about how hard it is to go on an independent expedition into Antarctica and how many layers of federal bureaucracy you actually, and how much money it actually costs and all that. They're like, go take a picture of the edge. It's like, yeah, right, you try. You got $1.5 billion sitting around. Like, no, it's cheaper to go into outer space, so to speak, than it is to take a trip all the way to the wall. But to go out there, I feel like that's what it would look like, something like that. When you get to the edge and it's just like this huge, maybe even spinning ice wall thing that's just goes all the way up and over, higher than any skyscraper. And I would love to one day get a spirit body and go put my hand right up on that wall and say, told ya.
Well, I hope you get that chance. If you get that chance, then I will surely eat everything I've said today.
Well, that's what I think. That's what stars look like when you zoom in on that with that last one and you flip across the screen. You've been flipping through some of my pictures and I'm like, oh, there's that one. Yeah, that one. That's like, apparently that's what it looks like when you zoom in on a star with a really powerful camera from down here. And sure, maybe it's interrupted by the light and stuff in our atmosphere, but a lot of them don't look anything like what they're supposed to look like. That's just
Well,
thing. You know, some of the stuff is just like we had another guy on before last time who was a flat Earth enthusiast, but he actually didn't believe the Earth was flat. He just was like enthusiastic or like you know, hobbyist about how many different interesting things go into this. I mean, to somebody who really doesn't have a scientific depth and they see, oh, that's what stars supposed to look like, and they see this, they're like, wow, that doesn't look like what they told me. It adds that little seed of doubt into the you know, the entire society and everything that we're learning, everything.
Can I just ask, where are these photos taken off? Because it looks like, you know, you've just screenshotted it. So are these real, Stephen? Any idea?
The person who posted that, and I'm sorry if these are like, I mean, if any of these are copies, like this is just me screenshotting random people's stuff on Facebook or whatever. That's like, oh, that was cool. And that's not the only way I get stuff. That's just a cool way to get pictures because I'm not all tech savvy and the screenshots the one. But the person who posted this was saying that these are pictures of stars taken from Earth through a like telescope or something like that. So you know,
So there's no actual evidence for that then. We just
yeah, you know. So you have to. The point of this is if you're going to take what NASA says the stars are planets, because some of these they'll zoom in and be like, this is Venus, and it'll show what Venus is looking like through a telescope, and it looks something like this. But then you see right next to it what the what NASA says it looks like, and they're completely different, right? Okay, are we talking about this one's from the Hubble then? And yeah, okay, we don't have to look for atmosphere. So you see how it explains it in both models, but it's kind of cool for people to think and look at some of these things and be like, wow, what is there? Because I had never seen this picture of what stars apparently look like through a telescope until I started studying flat Earth. And yeah, it makes sense in both models, but that's another thing. I mean, it could go both ways. There's explanations in either model, which is why it still exists, why the argument is still there, why I haven't been convinced yet.
So is there any explanation for these photos, Stephen? Any idea?
I mean, if I wanted to, I could open up Paint and make those myself.
Yeah, well, yeah, that is true. And Photoshop, and you know, I've even got Adobe Illustrator.
So
Yeah,
stuff like that.
I don't think that helps either side's argument.
No, there's also another one that doesn't quite help, and I'm not 100% sure why you actually sent it to me in the first place. If I can just bring it up, can you see that one?
Oh yeah. See, some of these are like these are a lot of. I'm not saying that these are necessarily like my pieces of evidence that I use because, like, as I hope you would understand, the pieces of evidence that I have are more things that I would prefer to just use my mouth to describe and then refer to what other people have said. But some of these are like the one with the Egypt and Mars. Like this is the kind of stuff that comes out of Flat Earth Society groups where you're like, look, this is apparently a picture of Mars, and this is apparently a picture of Egypt. Well, okay, but it could easily Photoshop. So that's my whole point. Is all of these things that are like little, and that's why I sent like a rapid of a bunch of these ones. Like these are totally goes back to my main point, which is a lot of these facts are unverifiable. And I want to know what are those facts that are right in front of our face that are verifiable that we can use. Because this one, I mean, this is one where if it's a thing, then the only explanation the globe person would have is, well, that was Photoshopped. And so
you don't even need to Photoshop it really because it's the same photo. You just change the color. The color's just been changed, and somebody's put Egypt, which is correct.
Right.
But they've put a photo of Mars written at the bottom. So, you know, you can't use any of this evidence if you don't know where it's come from. It looks like it could possibly be a news report. We'd need to know what the newspaper was called so we can look at it properly and see what their reputation is for lying. You know, in England, we've got the Mirror and the Sun that just, it spouts out crap all the time, and you can never really trust what they say. Yeah. So I'm pretty sure Americans have got their own sort of papers like that.
Right, and I totally agree, and that's part of my point is it's not productive when we see things like this. Now, this could be intriguing, but then this is a rabbit trail, this picture alone. Because then
Not really. It's clearly the same picture, just the color changed on it.
Let me finish too, because the point is that it's not even worth going down the rabbit trail, because the obvious end of the rabbit trail is there's no way to verify that this is a real picture. It could easily be Photoshopped. So if you can use that for a photo that supposedly, which this doesn't, supposedly supports a flat Earth or an anti-NASA or whatever. Now, for example, if that picture, you wanted to go the rabbit trail, if that picture was genuinely something that was on a site with NASA, and then that was verified to be Egypt, and it was someone admitted to it lying. But why do that? Why go down there? It's a waste of time. The whole point of this picture is that you can't verify a lot of these memes and pictures. You have to logic it out through what you can verify, and you can't always just trust a picture, especially when coming from NASA, because I mean, then
Yeah,
they'll
but
say,
there's no
well,
evidence that this photo is from NASA. This photo is from I can't see why it's got anything to do with flat Earth at all, unless you're trying to prove that there's no other planets out there.
Oh yeah,
No,
obviously the person that made this meme was trying to say that they're faking Mars. Mars is not a real planet to go to. It's just a wandering star. I would agree that Mars is just a wandering star. It's not a planet that we can go to and walk on. But I would. Okay. All right. Ding, ding, ding.
Yeah,
But
why don't we stretch?
the point of the meme, that last one, is that it's an unverifiable meme. Some of these memes, and that's why I brought up some of these. I gave you some of these memes because some of these are really dumb and they don't help the argument either way. They just make a confusing rabbit trail of, is this person all you said, all this stuff. But to get down to the conversation about verifiable things is what I'm all about with the flat earth, and also I do have a bit of a passion for at least going and far enough down each rabbit trail so that people can see that there's still a reasonable doubt for somebody like myself who does believe that it's flat and has his reasons. There's still, I even today have not seen something that doesn't also have a reasonable doubt to it. And some of that doubt does go to, well, I get to the end of the argument, and if your facts are true, then it's flat. And if my facts are true, then it's gold. And the only way to get some of these facts is if you have a whole ton of money. So I'd love to find a deal breaker at some point. This is always a fun thing. I do have the wife beckoning. Sorry we couldn't get the time zones right, or you have enough time with me to touch on the time zones. But time zones work on a flat Earth model too. And spoiler alert. And I always appreciate the respect and the time you guys give me. And I maybe I was a little more rude this time. It's funny how many different things. I hope so. It's funny how many things there are to get into with this topic, but I hope I at least didn't make you think that I don't know the alternative viewpoint also, because I do also understand the basics and the 102, 104, whatever level understanding, college even, of physics, science, globe model, all that kind of stuff. I just hope that I could have explained a little bit how the flat Earth model works in some of these, and shown how there is an explanation in some of these rabbit trails, and in every of these rabbit trails, as far as I'm concerned. Appreciate the time, and I do have to check out and be finished today, but I'm open for free.
All right, brilliant. Thank you for joining us, mate.
Definitely. Thank you.
All right. Sorry for all the mix-ups today, but you folks take care. Great to meet you, Stephen. Sorry if I cut you off too much, talk too much also, but I appreciate the patience and the fun and all that. And we'll talk again. Take care, folks.
Take care.
Right.
Yeah.
Josh Hamer, everybody. All right.
Oh, he's still here. He's still here.
This touchscreen sucks.
Say that again.
This touchscreen sucks.
Well, he's either frozen or he's gone. See, once again, he hasn't convinced me that there's a flat Earth. And is it me that he doesn't really answer the questions properly? It's very quiet.
It's hard to tell. I think for most people, when there is some sort of uncertainty, talking a lot seems to help them convince themselves and convince other people of what they're saying is true. I think simple answers are better, and for me, I guess this would be kind of my last segment here. I tend to go with what makes sense, and I determine what makes sense by what data I can see and what data are verifiable with equations and with experimentation and with Jeff Bezos and Elon Musk launching these things into orbit, where if they use some sort of other mathematics based off of flat Earth, it wouldn't work. So my thing is, yeah, I absolutely believe that these things are real and that these things are happening. And the only way to believe that these things are happening is to understand how the Earth is spheroid. And I say spheroid because it's a little bit fatter around the equator.
Yeah.
Because it's spinning. But I mean, that's the only way the physics work out. So.
Yeah, that's what I find about flat earthers is they don't want to go out and do the proper investigations themselves. Flat earthers ask for globe proof all the time on Facebook, and they get sent it not just from one source but loads of different sources. And then you get a glober asking a flat earther to prove flat Earth, and they get bombarded by YouTube links. So that to me just says that they're getting all their resources, all their information from YouTube.
And there's always going to be, no matter what topic there is, no matter what conspiracy theory or whatever, there's always going to be anecdotal evidence. You're always going to be able to find something to say, this proves that this is right.
Yeah.
As soon as you step outside of your little box, it falls apart. The whole thing falls apart. And very few things, I can't think of a single thing that when the globe theory, if you want to call it that, when that theory is challenged, where it falls apart. Because every one of the theories or concepts that we use on a globe Earth, sometimes it will work with a flat Earth too. And it's fine that it works on both models.
Yeah.
But never on, it doesn't go the other way around. You know what I'm saying?
Yeah, definitely.
So I don't know. That's where my thoughts are as a pilot. Being on a round Earth or a flat Earth has nothing to do with how the plane flies, but it has everything to do with how we navigate. And it wouldn't work in any other way.
Before Joseph takes us out, because we've been going 2 hours now, and it's now 2 o'clock in the morning for me.
Yep.
On our last video that's on YouTube, there was a flat earther that made a comment, and I just want to tell you it, and I'd just like to hear your response, your personal response. He put all pilots you spoke to are either liars or brainwashed.
Well, my response would be, how did Orville and Wilbur fly? You know, the first two people to ever fly in the atmosphere of this Earth under powered machinery. It all started from there. Nobody told them that has nothing to do with flying an airplane, right? So the lie would have had to emerge somewhere along the way. Because once navigation started happening, once we started flying further and further distances, if it were a lie, someone would have had to say along the way, hey, we're once we start navigating, we're going to have to start telling people we're navigating using a different method, or I don't know. Because the one thing, even if you were just to use a map and compass, if you were flying east and west, the compass variation changes. So you can't fly in a straight line east and west. You have to turn. If you take this piece of paper and try to wrap it around somewhere that's not the equator, it's not going to be able to lay flat against the sphere.
Yeah.
Only a straight line would enable the paper to lay flat. So if you're going around the whole Earth, you can lay flat. Any other line, east and west, besides the equator, you're going to have to turn. There's no other way to do it. So every 50 miles or whatever, there's going to be a line on the map that has a different magnetic variation, and you're going to have to change course every 50 miles or so. And the very first man to cross the Atlantic was Charles Lindbergh in 1920 something or 1930 something. And the whole time, I think it was like a 17 or a 20 some hour flight. Every 10 or 12 miles, he would have to adjust course. He couldn't fly straight across the Atlantic. And if he didn't adjust course every 10 or 15 miles, he would have been like 30, 100 miles off from Paris where he was landing, and he wouldn't have made it across the ocean. He wouldn't have had enough fuel. So that's my main argument. And I mean, you go, yeah, that's all I have to say about it.
See, that's directly to you, Malik, who was kind enough to message on our YouTube video. I think he tried to have a go at me, but it didn't quite work out. And then he brought pilots into it, and I was laughing to myself, knowing that we've got a pilot coming on the next show. So I did say to him that I'll bring these up. He also, would you personally believe any pilot would say the Earth is flat?
If they did, it would have to be an argument based off of something other than aviation. Yeah, because I don't know how you would navigate a flat Earth. It would be totally different. You could fly straight lines to places. Straight lines would work.
See, can you be a pilot without knowing anything about navigation?
You could be. There are certain different degrees of pilot. Like below private pilot, at least here in the U.S., is kind of the first real pilot, and then there's like 2 or 3 levels below that. There's student pilot and sport pilot and recreational pilot. So I guess you could be one and not really have to know a whole lot about it. But I don't know how. Most pilots I know are also space enthusiasts, and the whole thing is interesting to them. So I don't see how that would work.
Gotta bring them on for an episode 3.
Yeah. Well, for me, it's been a really interesting and fun time. Less talking, the better, in terms of, the more you talk, the more I don't believe you.
Yeah.
And so
I'm back.
That's my last 2 cents.
He never really answered any questions. He goes on to something else. I don't know if anybody else noticed that.
I did. I tried to interject as much as possible and keep him on track, but that just wasn't happening.
And he'll be watching this now. Sorry, mate. I still think you're a great guy. You haven't convinced me of flat Earth whatsoever, but I do like you. You're a bit of fun.
Kudos.
Right.
Well, anyway, thanks again for having me. And if you have other discussions that you want me to be a part of, I'd probably join you. Give me a little briefing, and
brilliant.
I'll hop on.
Yeah, we've definitely got plenty in the pipeline anyway, so we'll definitely, definitely you and Jonathan as well. The pair of you together, I think, would be just a show itself, because he's good with his conspiracies. He doesn't generally believe in them. But he really gets into them. He's really fascinated by them all. He's got all sorts of conspiracies. So perhaps it'd be good to get them both together.
Yeah, 100%.
Right, I'll let you finish the show then, Joseph.
Well, you heard it, folks. Thank you, huge thank you to our guest and pilot, Steven. So awesome to have you on the show. Awesome. Another shout out to John Finch, Outfox Studio. Check this out on YouTube. Catch us for a third episode. I think you're going to really enjoy it. That being said, thank you so much for tuning in. This has been Let's Talk Flat Earth 2. I am your host, Joe Thompson. Thank you so much.
Also, if you've enjoyed what you've watched today, please don't forget to subscribe, like, and even comment. We're not like Flat Earthers. We won't ask you to support us by giving us money. Like I say, all we want is a subscription, a like, and a comment. That's all it's going to cost you.
Catch me on social media as well. I have an audio podcast, The Pine Skull Project, Facebook, Instagram, J Thompson 29. I'm a stand-up comedian, so it's only going to get funnier. Maybe. But this has been Let's Talk Flat Earth 2. Good night, folks.